Alright, in this video we're going to talk about 1.6 day 1, the graphs of the other trig functions. So we have a lot to talk about, so I'm going to try to move pretty quick through this video. The first thing we're going to look at is the graph of the parent function of tangent of x. So if we think about tangent, that is the y value over the x value. You'll notice that we're not going from 0 to 2 pi. We're actually going to go from negative pi over 2 to pi over 2 for our tangent function. So if we think about y over x for tangent, that's going to be at negative pi over 2, that's going to be negative 1 over 0. So we're actually going to be undefined here. So it does not exist at that point. If we go to negative pi over 4, that's going to be negative radical 2 over radical 2 over 2, which is going to be 1. 0 is going to be 0 over 1, which is going to be 0. Pi over 4 is going to be 1, and pi over 2 is not going to exist as well. So at negative pi over 2 and pi over 2, we actually have vertical asymptotes because we're dividing by 0, and it's not going to cancel out. So we're going to get these little vertical asymptotes there. At 0, we're 0. At negative pi over 4, we're negative 1. At pi over 4, oops, that should be over here, sorry. At pi over 4, we're going to be at 1. And what this is going to look like is it's going to kind of curve like this and go up like that. Repeating the periods are going to end up looking like that. So it's going to repeat this thing over and over and over again. So since we're not going from negative pi over 2, from 0 to pi over 2, we need to change what our equations are going to be to solve for our asymptote. So instead of 0 and pi over 2, looking at the table we just made, we're going to want to go from negative pi over 2 to pi over 2. That's going to give us the endpoints, and then we can split those into pieces from there. So let's look at an example of graphing this. We're going to say graph 3 tangent of 2x. So we're going to want to say 2x equals negative pi over 2, and 2x is going to equal pi over 2. Solve those, we're going to get x equals negative divide, so we're going to say negative pi over 4. And this is going to give us pi over 4 over here. Halfway in between those is 0. Halfway in between these is negative pi over 8. And halfway in between those is going to be pi over 8. So thinking about the points on our parent function, we went from undefined to negative 1 to 0 to 1 to undefined. But just like before, that negative 3 is going to change these points. So negative 3 is still going to be undefined here. That's going to make this a positive 3, 0, negative 3, and undefined there. So at negative pi over 4, we have an asymptote. At positive pi over 4, we have an asymptote. At 0, we're going to be 0. At negative pi over 8, we're going to be at positive 3. Negative 3 for pi over 8. And our one cycle is going to look like that. If we wanted to add more, we could jump over and put a couple more in if we wanted to. So there's going to be tangent. Cotangent is going to be very, very similar, except cotangent is not y over x, but x over y. So this time we're going to go from 0 to pi when we're looking at our parent function. So if we're looking at x over y, 0 would be 1 divided by 0, so we're going to get our undefined here. And that's why we're starting at 0. Pi over 4 is radical 2 over 2, so that's 1. Pi over 2 is 0 over 1 is 0. 3 pi over 4 is going to be negative 1 and does not exist at pi. So now we're going to get our asymptotes at 0, pi, and if you wanted to keep going, you can get one at 2 pi. If you wanted to go this way, you can get one at negative pi. But if we look at what's going on here, we're going from positive 1 to 0 to negative 1. So this one is going to have the same shape as tangent, except it's going to be go in the opposite direction. So tangent was increasing, cotangent is decreasing. And much like tangent, we're going to have to change these things. This time we're going to go from 0 to pi for our cotangent. So let's look at a quick example of what that's going to be like. So 2 cotangent of pi over 3, so we want to say, x over 3, so we want to say x over 3 equals 0, x over 3 equals pi, so this is going to give us 0 to 3 pi. Halfway between 0 and 3 pi is 3 pi over 2. Halfway between 0 and 3 pi over 2 is 3 pi over 4. Halfway between 3 pi over 2 and 3 pi is going to be 9 pi over 4. And our parent function goes from does not exist to 1 to 0 to -1 to does not exist. And multiplying it by the 2 because of that, we're going to go from does not exist to 2 to 0 to -2 back to does not exist. So we get an asymptote at 0. This doesn't go all the way to 3 pi. So let's add a little bit more here. Alright, we'll call that 3 pi. So there's our asymptote there. At 3 pi over 2, right here, we are at 0. At 3 pi over 4, which is right here, we're going to be at 2. At 9 pi over 4, which is going to be over here, we're at -2. So it's going to look like that. So we have 2 more functions. We need to talk about secant and cosecant. So we're kind of combine these into one spot over here to kind of save a little bit of room. But if we think about what's going on with these, cosecant is 1 over sine. Sine at 0 is 0, so cosecant at 0 is undefined, does not exist. Sine is also 0 at pi and 2 pi, so our cosecant is not going to exist at those 2 points. At pi over 2, sine is 1, so cosecant is 1. At 3 pi over 2, sine is -1, so cosecant is -1. Thinking about the secant graph, cosine is 0 at pi over 2 and 3 pi over 2, so 1 over cosine, or secant, is not going to exist there and there. We're going to get a 1, -1, and 1 here. Now that's not really all that important. I mean it is, but it's not really how we're going to graph these things. How we're going to end up graphing them is that we're going to look at sine and cosine, and then we're going to use those to help us graph secant and cosecant. So what I mean by that is if we graph the sine function first, so we know sine is going to look like this. Anytime we hit the axis, we know our cosecant is going to have a vertical asymptote. It's not going to be defined because if sine is 0, 1 over sine is undefined. So we notice that they share these points 1 and -1. So what we're actually going to do is graph our sine function, graph what our asymptotes are. We know they share the maximum and minimums. So really what cosecant looks like is a bunch of alternating concave up and concave down parabolas that are bound between these asymptotes. So it's going to continue in this direction as well. We'd have another concave down over here, but we're just looking at one period of cosecant. Secant is going to be the same thing. So we're going to want to start with our graph of cosine. So cosine goes from 1 to 0 to -1 to 0 to 1. And when we cross the axes, we get our asymptotes. So we're going to end up having something that looks like that. Now obviously these are going to continue over here. But that's going to be our graph of cosecant. So we have two quick examples, and then we'll call it quits on this video. Alright, the first example is going to be y equals 2 cosecant of x plus 4. So what we're really going to want to think about is the graph of y equals 2 sine of x plus pi over 4. And then that way we graph this function and we'll be able to graph our cosecant. So we want to think about bx minus c equals 0 and 2 pi. So we're thinking about x plus pi over 4 equals 0, which gives us x equals negative pi over 4. And we want to think about x plus pi over 4 equals 2 pi, which gives us x equals 7 pi over 4. So we know we're going to start at negative pi over 4. We're going to end at 7 pi over 4. Halfway in between those is 3 pi over 4. Halfway between these is pi over 4. And halfway in between these is 5 pi over 4. Our original function goes 0, 1, 0, negative 1, 0. So our new function multiplied by 2 for the amplitude is going to be 0, 2, 0, negative 2, 0. So to graph sine, we know we have negative pi over 4, 0. Pi over 4, 2. 3 pi over 4, 0, 5 pi over 4, negative 2, and 7 pi over 4, 0. So we know we have our function that looks like this. So there's our related sine function. So that gives us asymptotes here, here, and here. So our cosecant function is going to share that maximum point. Open up that way, open down that way, and that's going to be our cosecant function. So this video has kind of gone on long enough. There's one example left, but it's going to be the same idea. We're just going to want to graph our cosine and then get the secant function from that. So I'll leave that one up to you guys. We'll see you in the next video.